This video discusses integer exponents and the rules of exponents basically, and order of operations. So first, exponents, something raised to a power. A is called the base, n is called the exponent, so when we have 8 to the power of 4, that means that our base is 8 and our power is 4. And it really just means 8 multiplied 4 times. Some things to remember: a to the 0 equals 1 and a to the negative n equals 1 over m. But some of you probably were taught that a to the 0 equals 1 and you're just supposed to memorize that. Well, it really comes from these rules, right? The product rule. Hopefully you remember that if you have a to the m times a to the n, it's a to the m plus n. You add them up because a to the m just means you have m many of these, and this means you have n many of these, right? So you've got a. You've got m many of those, and then over here you've got a bunch more, or this time there are n many of those. And so when you put them all together, isn't that going to be m plus n many of them, right? Similarly is why a to the m over a to the n equals this, because if you have a bunch of a's on top and some a's on the bottom, don't you cancel out and see how many you're left with, right? The number that were on top minus the number at the bottom. So if you have, say, 5 3's on top and 2 of them on the bottom, don't you cancel 2 of them and you're left with 3 cubed, right? Well, this is why a to the 0 equals 1. Because if you have, let's say, 3 2's over 3 2's, isn't that the same thing as 2 cubed over 2 cubed? And we can see very plainly that that's going to be 1. But according to this rule, right, it's also 2 to the 3 minus 3, which is 2 to the 0, which we see equals 1. So that's really why something to the 0 equals 1. It comes from the quotient rule. The product rule, or I'm sorry, raising a product to a power means that each thing is raised to a power. That's really important, because if you had, let's say, 3x and this whole thing is being squared, that is not the same thing as 3x squared. Because on the left-hand side, you're raising everything to the power of 2. On the left-hand side, you're really getting 3x times another 3x, and you get 9x squared, because you end up getting 3 times 3 is 9, right? So you had 3 squared and x squared, which is different. So that's a really important one to remember. And then, of course, raising a quotient, you just raise each piece to that power, just like we're raising each piece here, right? The a gets raised to the m, the b gets raised to the m, same thing here. The power rule is when you have something raised to a power again, and that's where you multiply, right? It's a to the m times n. So if you had, say, 2 cubed to the 4th, that's 2 cubed times 2 cubed times 2 cubed times 2 cubed. Well, there's 3 of them here, 3, 3, 3, right? So isn't that 3, 6, 9? Isn't that going to be 12 of them? And that's 3 times 4. Here are some examples. I worked through some on the previous slide. You can see some more showing you the same thing, right? You add these two and you get 3. Because isn't r to the negative 2 the same thing as 1 over r squared? So this really becomes 1 over r squared times r to the 5th, which is r to the 5th over r squared, and 5 minus 2 is r cubed. Same answer, right? So all these rules work in any direction. Here's your example where everything is being raised to the power of 4. So there's 3 to the 4th, and then a to the negative 3 to the 4th, and then we can rewrite it this way, right? Negative exponent just goes to the bottom, but this only works for multiplication, right? We can only flip these things around for multiplication. So here's our simplification rule here of 9 minus 4. Here's everything being raised to a power of negative 3. Right? And then what's happened here? The 27 came from the 3 to the negative 3, so it goes to the bottom, becomes 3 cubed. And then on the next step, this b also goes to the bottom and becomes a positive 6. Just like here, p to the negative 24 becomes 1 over that. So we've seen this example over and over and over again, that if we have something raised to a negative number, it's 1 over that to a positive. And the same goes for if we have a negative down below, it becomes positive up above. If we have 1 over b to the negative 3, that's going to be b cubed. Because really what happens is this b to the negative 3, right, becomes 1 over b cubed, right? Just this piece ends up being that. And then when you have 1 divided by a fraction, you multiply by the reciprocal, i.e. flip it around, right? And that's where you get b cubed. Next are our rules of order of operations. You might remember PEMDAS. Please excuse my dear Aunt Sally, and it represented parentheses, exponents, multiply, divide, add, subtract. Most people forget that you're supposed to do these two in pairs, right? So you do all the multiplication and division together from left to right, and then all the addition and subtraction together from left to right. If you forget that, you can always make it PEDMSA. People everywhere do math so accurately, and now you can just do all the division first, then come back and do the multiplication, do all the subtraction first, then come back and do all the addition, and you'll actually still get it right. And that's because of the commutative law of addition and multiplication. That's the only reason why it works. Here's an example, right? First thing, we do what's inside the parentheses. So we do 9 minus 6, and that's where we get the 3. Next thing is we do the exponents, so 3 cubed, 27. Next thing is multiplication. Last thing, addition, subtraction. Right? Same thing with this bottom one. First we do what's inside the parentheses, so there's the 5, right? Nothing else has changed on the top. On the bottom, first thing we did was powers, right? Because there weren't any parentheses, so we moved on to exponents, and there's that stuff. Okay, now we can do division, so there's our 3. There's no more division or multiplication, no division or multiplication, so we go straight to addition and subtraction on the bottom, and that's where the 31 comes from. And so now on the top we still have to do our addition up there. 23 over 31 is our final answer. That's it.